Okay, so section 4.1 is called the chain rule. So it says we know how to find the derivatives of functions like f of x equals 3x minus 4 to the second. We just FOIL and then multiplied it all out and then took the derivative. But if we add something to the 15th power, obviously you don't want to multiply 3x minus 4 times itself 15 times. So in order to do this, we use something that's called the chain rule. It's a really easy concept, but it's hard to understand when you look at the reasoning. So we're just going to take the derivative as a new variable. Well, not the derivative. So we're going to treat the derivative like this. 3x minus 4 was a new variable, u. So then you'd really be taking the derivative in terms of u to the 15th. Okay, so that's what this is now changed to. That would be really easy. You would just write 15u to the 14th. But you also need to multiply by the derivative of u. I always say multiply by the derivative of what's inside. Okay, so here's why. So suppose you have the derivative of y in terms of x. Okay, we're treating it like the derivative of y in terms of u times the derivative of u in terms of x. Okay, so let me write it out. So derivative of y in terms of x equals derivative of y in terms of u times derivative of u in terms of x. Okay, derivatives are rates. So this would be really simple if you guys were like in chemistry class and I told you to convert units from feet per second to miles per hour. You guys would know how to do that, right? Anything on top has to cancel with anything on bottom. Same thing. So in physics and chemistry, you often cancel units. This is the exact same concept. So your rate of change over y or the rate of change over x equals, so it's like you're doing like feet per second, things like that. Okay, so you're doing the exact same thing. Okay, so chain rule. Like I said, when you see it all written out, it's very, very confusing. But you just need to remember, take the derivative of what's inside at the end. Just tack it on. All right, so it says if g is differentiable at x and f is differentiable at g of x, then the composite function, so composite means composition, f of g, is defined by f of x equals f times g of x. Sorry, I know it's yellow, I'll fix it. Okay, it's differentiable, and f prime is given by the product. Okay, it might just be yellow. This drives me crazy. Okay, so it's given by the product. F prime of g of x, so the inside stayed the same, times g prime of x. So the inside is the same, and then the second part is derivative of inside. Okay, so that's kind of our Newton notation with the primes. So in Leibniz, if you have y equals f of u and u is equal to g of x, so that means you have f of g of x, then the derivative of y in terms of x equals, you take the derivative of the first part with the g of x inside. So derivative of f, or let me, it's kind of confusing. So you take the derivative of the y value, but it was in terms of u, so with u's, so all of its variables were u. But then you know that u was really g of x, so you're taking the derivative of u in terms of, that was all in with x. So the variables were all x for that. Okay. So example 1, it says, what's the inside part of each function? Find the derivatives of the functions using the chain rule. So these are pretty easy. What's the inside part for number 1? 2x minus 4. Okay, a lot of textbooks will have you actually write this as a composition. So they'll say, okay, if you were writing f of g of x, you don't have to write this. F is the square root of x. G is 2x minus 4. The inside part is g, the outside part is f. So do you see how if you did f of g of x, you plug in 2x minus 4 for the square root? Okay, I'm not going to have you guys do that. I just want you to remember the rules of the chain rule. So you just need to take the derivative just like normal. So we're writing this as 2x minus 4 to the 1/2. So if that had been a variable, we just do 1/2 out front, 2x minus 4 to the negative 1/2. And then we always remember that that wasn't a variable, so you have to take the derivative of what was inside. So 2. Clean this one up a little bit. You have 1/2 and 2 that cancel. So it's 1 over the square root of 2x minus 4, because negative 1/2 power is 1 over the square root. Make sense? Okay. What's the inside part of 2? Just right there, x squared. We know how to find like the derivative of a sine of u. Derivative of sine of u would be cosine of u, right? So we know how to do that derivative. All right, so f prime of x is treat that inside part like a variable. Its derivative would be cosine of that inside part. So cosine of x squared. And then times derivative of inside, 2x. So we write 2x cosine of x squared. And that's your answer. Okay, makes sense? What's the inside part on number 3, though? Yeah, Victoria, do you have a question?
Well, yeah, if you go back to the second one, why is it just x squared? Why isn't it
Because you're thinking of like what's in parentheses. So if I know how to take the derivative of sine of u, right? It would be just cosine of u. That's right here. So it's cosine of u. Okay, then you multiply by the derivative of the inside part. So the inside part was only the u part.
Okay.
So the part that you're thinking is a new variable. Go down this way. Okay. So now, there is no inside part. There's no parentheses. Are there really parentheses there? No, not x. It's not sine of x squared. That was the last one we did. It's, the way I said it was kind of like it. So it's sine of x quantity squared, like that. So the inside part is really sine. So think of the sine as being the new variable. So that's u. How do you take the derivative of u squared? 2u, right? Derivative of u squared is 2u. So the derivative of f is going to be, think of this as u squared. It would be 2 times whatever that inside part was, u, times the derivative of what was inside. So what's the derivative of what's inside? Cosine of x. That's your answer. Okay, you guys try number 4 and 5. So try 4 and 5. So as I walked around, you guys had good answers. So the first one should be 100 times x cubed minus 4x plus 2 to the 99 times the derivative of what's inside, so 3x squared minus 4. Make sure you're writing parentheses around the 3x squared minus 4, just so you know that whole thing's multiplied, not just the 3x squared. And then the other thing that a lot of people will mess up on is they put the derivative here. Like a lot of people will put 3x squared where I've just underlined, like 3x squared minus 4. So make sure you know you're just doing the same thing that it was before. Okay. Some of you guys were like, is this it? Is this as far as I go? Yeah, if there's no like negative powers or anything that's really easy to multiply out, then just leave it. Like some of you guys multiplied the 100 into the second piece, which is okay. So you could have 300x squared minus 400. But I would probably just keep it the way it is. You can't multiply it into the first piece, though, because if I had x minus 2 squared, I can't just bring like a 4 in there. You know, I can't say it's the same as 4x squared minus 8. Or 4x minus 8 quantity squared, I guess, is what you're doing. Okay. So 5. So first think about what the inside part is and what power that has. It's x squared plus 1 to the negative 1/4 power. So now when you take the derivative, so f prime of x, you get negative 1/4 times x squared plus 1 to the negative 5/4, so subtract 1 from the power, times 2x. So the only thing I would really do here is combine the negative 1/4 and the 2x, because the numbers reduce 2 and 4, make 1/2. So it's negative 1/2. And then if you have a negative power, you can leave it on the top as a negative power, or you can put it on the bottom as a positive power. It doesn't matter. So you can do 5/4, or you can do the 4th root raised to the 5th. Oh yeah, I forgot about my x, didn't I? So that goes on the top. So point for Victoria. Okay, so that's it. All right, now 6 is hard. When I was really little, I always made those like gum wrapper chains. Did you guys make those?
Yeah.
I made those all the time. I was like obsessed with them. All right, so this is kind of like a gum wrapper chain. It kind of goes on forever. So you have to do like inside part, inside part, inside part. So do you guys want to attempt it first? No. Okay, so think about what your inside part is first. So tangent of x is your inside part. So if I was taking the derivative and I'm thinking like tangent of x is like a u, my derivative would be f prime of x equals sine of cosine. Oh wait, I've already messed it up. Let me think. Let's do this whole thing. So if I just had sine of something, how do I take the derivative of it? Cosine of something, right? So we're first going to start out with cosine of the whole inside part. So cosine of tangent of x. But then we need to multiply by the derivative of what's inside. So what is the derivative of cosine of tangent? Negative sine of tangent. And now the inside part is tangent. So times, what's the derivative of tangent? No, secant squared. You guys should know that. All right, so that's your final answer. So all I would do is bring the negative out front. So it's going to be negative cosine of tangent. Not cosine squared. Some of you guys think that. It's always, you always keep the argument the way it is. So cosine of something, that's called the argument. Times sine of tangent times secant squared x. Like that. Those ones are the hard ones. How did I get negative? Just this negative that was here, I just pulled to the front. Just because I don't really like you wouldn't write x squared times negative 5. You wouldn't leave it like that, right? You'd write negative 5x squared. So just move it around. Okay, what? Okay, so let's go back through it. So think about your inside part. If I just had sine of something, you could take the derivative. It would just be cosine of something, right? So if I had sine of u, the derivative would be cosine of u. But we have sine of a big thing. So it's going to be cosine of that big thing times the derivative of the big thing in the middle. So the derivative of cosine, so this is the derivative of cosine tangent. And then, so that's the derivative of cosine tangent. And then we took the derivative of tangent, right?
Yeah.
So we did chain rule 3 times. Fun, fun. All right, number 7, find the equation of the tangent line y equals 2x plus 4 to the 3rd times x squared minus 1 to the 4th at x equals 0. Okay, this is chain rule and what other rule? Product rule. Here's your 2 pieces. So I'm going to have y prime equals first times the derivative of the second So the derivative of the second was 4 times the quantity of x cubed minus 1 cubed times 3x squared. Everybody with me on that? Plus the derivative of the first, so 3 times 2x plus 4 to the second times 2 times the second part normal, so x cubed minus 1 to the fourth. What's nice about finding the slope? Where did I tell you to find it at? At 0, that's nice, because all these x's go away, right? So it's just 4 to the third times 4 times negative 1 to the third times 0. Wish I would have seen that first. Plus 3 times 4 to the second times 2 times negative 1 to the fourth. So the whole first half is gone. So I have 16 times 3, so 48 times 2, so 96 times positive 1, so 96. Since it's at 0, that means it's 0, comma, go back to your original, plug in 0. What do you get for y? 64. So 4 to the third is 64, guys. So your final answer, that's your y-intercept. It's 0, comma 64, so that's b. So it's y equals mx plus b.